easily you'll get 10 marks. Okay. In this network, the switch is closed at t is equal to 0. Okay, assuming all the initial conditions 0. Initial condition means initial current in the inductor is 0, initial voltage in the capacitor is 0. You have to find I of t di by dt d square I by t square at t is equal to 0 plus. 0 plus means just after switching you have to find these values. So I already told, if they give series circuit, they will ask find I di by dt d square I by dt. If they give parallel circuit, they will ask find V dV by dt d square V by dt square. So it is a series network. So I, they are in the series. This is the I of t. So we have to find these values. So let us start with before switching. Okay, the switch is closed at t is equal to 0 plus. For t is equal to minus infinity to t is equal to 0 minus, that is this period. This period is minus infinity to 0 minus. This point is, okay, exactly at this point the switch is closed. This switch is closed exactly at t is equal to 0. Okay, that is called as t0 plus. And for this it is called as t greater than 0, and finally it will reach steady state at t is equal to infinity. Okay, so before switching the switch is open, current is 0 because the switch is open now. At t is equal to 0 only the switch is closed. In this period, from this point to this point the switch is open, no current is flowing, so current is 0. IL of 0 minus is 0 amps. At t is equal to 0 minus, that is minus infinity to 0 minus, the switch is open, no current is flowing because circuit is open. Okay, no current, and because of no current, no initial current in the inductor, and capacitor also is not charged, so initial voltage of the capacitor is 0 volts. This is 0 amps. Next, just at t is equal to 0 plus, at t is equal to 0 plus the switch is closed. Okay, please see here, the switch is closed at t is equal to 0. That means the switch is now closed. This is closed, switch is closed, actual switch is closed, physical switch is closed. Resistance remains always resistance only, no changes in the resistance, but capacitor and inductors, they behave differently. So just remember this table, initial conditions. Resistance remains resistance, no change. Inductor at t is equal, just after switching, inductor acts as open circuit, capacitor acts as a short circuit. I have to remember this, I told no, capacitor assume like your battery, whenever you plug in immediately it will start charging, so it should act as short circuit. Inductor, just after switching, it acts as open circuit. Okay, now capacitor acts as, which is capacitor here, right side is capacitor, this is inductor. Capacitor acts as short circuit, this is acts as short circuit. Capacitor acts as short circuit, inductor acts as open circuit. This is open, this is open, this is short circuit. Capacitor short circuit, inductor open circuit. Again also we see any current is flowing in the in the circuit. Even though capacitor acts as short circuit, still circuit is open because inductor is there. Whenever inductor is there, just after switching, inductor acts as open circuit. So even the capacitor acts as short circuit, no current is flowing in this one. So initial, after switching also, just after switching, t is equal to 0 plus means just after switching, current in the circuit is 0, and capacitor also not start charging. So in order to charge, capacitor to charge, there should be some current should flow here. Okay, so just after switching it, that's what I told you, in your mobile, if it is 0%, you plug into charge immediately for 1 sec, just for 1 microsecond you switch on, immediately if you open and check the voltage, still it will show 0 only. So just after switching, capacitor voltage is 0 volts only. Okay, this is over. I of 0 plus is already over now. It is 0 amps. So you have to write unit also, amps, 0 amps. This is voltage V. So now next this one. For t greater than 0, you have to write integral differential equation. This is which is closed for t greater than 0. For t greater than 0, you have to write equation. It is voltage V R L C. So you can write this is minus plus plus minus plus minus plus minus. They use different notation, so I'll use my notation minus 100 or 10 plus plus 10 into I of t plus L into di by dt plus 1 by c integral of I of t dt is equal to 0. This is minus 100 plus this is I of t, you have to write here, plus L into di by dt 1 by c plus 1 by c integral of this is also wherever I is there you write I of t dt is equal to 0. Next we have to write at t is equal to 0 plus because at just after switching, okay, because they ask you to find di by dt just after switching. I want to find di by dt value. This is general equation. This is a general equation minus 10 10 into I of t L into di by dt 1 by c integral of this is a voltage of capacitor, voltage across inductor, voltage across resistance. Applied voltage is equal to drop across resistor, drop across inductor, drop across this. This is general equation for t greater than 0. I wrote integral differential equation. Now at t is equal to 0 plus, because they ask you to find di by dt at 0 plus. At t is equal to 0 plus, 10 remains 10 only. So this minus, no, I am writing for this. Both the notations correct because some they consider rise in voltage as positive, fall as negative. So here I am using whichever coming first now, minus, plus, plus, plus. So what earlier it was written here, it is plus, this is minus, minus, minus. Throughout if you multiply with negative, same equations you are going to get. Okay, now this minus 10 into I of 0 plus. I of 0 plus you have to find out. Okay, di by dt at 0 plus and 1 by c integral of I of t dt. This is voltage across capacitor. Now at t is equal to 0 plus I have to find out. At t is equal to 0 plus, this minus 10 remains as it is. 10 into I of 0 plus. What is I of 0 plus value? I of 0 plus value is 0. I of 0 plus value is 0. So minus 10 plus 10 into 0 plus di by dt 0 plus, and this is a voltage across capacitor. V of C is voltage across capacitor because the applied voltage is equal to drop across this plus drop across this. This is VR, this is VL, this is VC. T is equal to 0 plus means what? T is equal to 0 plus means just after switching, if you check the voltage of capacitor, okay, just after switching 0 to T, no, integral 0 to T. T is equal to just after it means there is no time happened. Okay, this is also 0. Delta T is 0 only. Okay, if delta T is 0, this voltage is 0 only. 1 by c integral of I of t dt. Delta t just after switching, there is no time, just after switching, just that instant. So at just instant delta t is 0, no? So this voltage is 0. Capacitor voltage, if I put battery to charge and immediately switch on and switch off and check the voltage, its value is 0 only because it is there, we are not given any time to charge only. So just after switching, capacitor voltage is 0. So delta t is 0, no? So this capacitor voltage is also 0. So we left with minus 10. This is also 0. So di by dt is equal to 0, and this minus 10 if you bring it to right side, this minus 10 if you bring it to right side, its value becomes plus 10. Okay, plus 10, and it is I by t. Unit of current is amps, time is seconds, it is 10 amps per second square. Now once again I have to find d square I by dt square. To find d square I by dt square, you can differentiate this equation. first equation, where we have minus 10, 10i of d. That equation you have to differentiate equation number 1 once again. Differentiation of 10 is 0. It's a constant. 10 is constant. It is 0. Differentiation of 10i of t. It is 10 di by dt plus L d square I by dt square. And now 1 by c. 1 by c differentiation of integration. Differentiation of integration will get cancelled. We left with 1 by c. 1 by n micro. Micro is 10 power minus 6. 10 micro. And differentiation integration get cancelled. You will get only I of t is equal to 0. Now at t is equal to 0 plus. At t is equal to 0 plus. This is I wrote no plus plus everywhere I wrote. That notation is I'm using different notation here. So plus 10 di by dt 0 plus, and 1 into d square by dt square, and 10 into 10 power minus 6 is from plus 6 minus 6, this is 10 power 1. Okay, 10 power 1 and minus 6 plus 1 is 10 power minus 5. 10 power minus 5 into I of t, and substitute t is equal to 0 plus. Substitute t is equal to 0 plus. 10 into di by dt, t value is 0 plus, d square I by dt, t value is 0 plus, 1 by c, t value is equal to 0 plus. Let us find. Now di by dt you have to take from the previous value. Previous value di by dt is right here. 10 into di by dt is 10. Okay, this value is 10 plus d square I by dt we have to find out. Okay, we have to find out d square I by dt square at 0 plus okay, plus 1 by 10 power minus 5 and I of 0 plus. I of 0 plus is how much? I of 0 plus is 0 because at t is equal to 0 plus, capacitor acts as short circuit but inductor acts as open. So I of 0 plus is also 0. I of 0 plus is also 0 because of reason open circuit. Okay, so this is also 0. This is 0. So d square by dt square is equal to, okay, this plus 100 now. If you bring it to right side, it becomes minus 100. 10 into 10 100 now, that if you bring it to right side, it becomes minus 100. And its unit is ampere per second square. Why it is second square? Mean denominator is t square. Okay, it is d square I by dt square. It is not di square by dt square. It is d square I by dt square. Okay, it is minus amps per second. It's a very, very important repeatedly asked problem. So don't get confusion. Sometimes they may give general problem like this. For the circuit shown, the switch is closed at t is equal to 0. Find I di by dt, d square I by dt square. This RLC. There we use the values of RLC, but it's a general problem. In this general problem, wherever R and LC value, no, you keep same values of RLC only in the entire circuit. For t is equal to 0 minus, okay, current is 0, initial current is 0, and voltage is 0. At t is equal to 0 plus, switch is closed. Switch is closed, but inductor acts as open circuit here and capacitor acts as short circuit here. Still the circuit is open, so I of 0 plus is also 0 amps. For t greater than 0, write integral differential, that is k value you have to write. Applied voltage is equal to V is equal to R into I of t plus L into di by dt plus 1 by c I of integral of I of t dt. At t is equal to 0 plus, already di by dt term is there. So at t is equal to 0 plus, V is equal to R into t value substitute as t plus, L into I value substitute as t plus, and here also I t value, this is nothing but initial voltage across capacitor, and delta t we are giving just after switching. Delta t is 0. So initial voltage of the capacitor is 0. So LDI by dt is equal to LDI by dt. This is I of 0 plus is also 0. This is 0. Initial voltage across capacitor is also 0. So di by dt is equal to V by this L will come. Di by dt is equal to V by L. So in this problem, what is V? This problem, what is V? 10. L is 1. So 10 by 1 is 10 ampere per second square. Similarly, if you differentiate this equation once again, differentiate this equation number 1 once again, differentiation of V is 0. R into di by dt, R into di by dt, L into d square I by dt square. 1 by c integral and differentiation will get cancelled. Integration differential will get I of t. Again substitute t value is equal to 0 plus. So r into d square I by di by dt at 0 plus L into d square I by dt 0 plus 1 by c integral of 0 plus. So here also I of 0 plus at t is equal to 0 plus I of 0 plus is 0. So this term is 0. This is 0. And we had to find out d square I by dt square. So di by dt is how much? This di by dt is this V by L. So VR, if I substitute V by L here, VR by L will get VR by L, and here one more L is there, you have to divide by that. So VR by L square. So easily you can find for general circuit also, or you can also calculate for different. And in the exam, most of the time they asked with these values only. So it is very, very important question. Revise 2-3 times before the exam, and please try to write it in your worksheet and practice. Okay, and don't forget, just after switching, inductor acts as open, capacitor acts as short circuit. But t is equal to infinity, capacitor acts as open, inductor acts as short. Okay, thank you.